Well, good afternoon and welcome to the last session in the Alfa Laval conference room. And we are hearing from Alfa Laval, who made the room possible. This afternoon, we're going to listen to Louison Roy and Denis Martin speaking about grow yields and profitability with brewing technologies for faster tank turnaround. Please welcome Louison and Denis.
Hello, it's a pleasure to be here. It's a very nice region as well. I just arrived yesterday from Denmark. So the presentation is going to consist in two parts. There's going to be a focus on the dry hopping process, and that's going to be me that is going to cover it, and then my colleague Louison is going to cover the separation process. And we're going to see how we can actually optimize the dry hopping, how to cut loss, how to reduce the dry hopping time, which is something that becomes more and more important nowadays. We saw that earlier today in different presentations. But we can directly dive into dry hopping. I think that everyone knows what dry hopping is, so I'm not going to explain what dry hopping is, but it's interesting to see actually all the problems that are related to dry hopping. And these type of pictures are probably quite familiar to some of the brewers here. And they are related to the nature of the hops. Most of the brewers are using hop pellets to dry hop, T90s, T45s, etc. And those hops are very dry. It's around 95 to 98 solid content. And it means that as soon as they are in contact with a liquid, they start swelling. And they basically start swelling up to, and they take up to 6 to 7 times their volume. If you, for example, don't think of that or you don't consider that and you have some dead ends, there is no flow, these hops in a confined place are going to create clogs, for example. That's one of the problems that can be related to dry hopping. Sometimes it's so hard that you can basically not flush that with a CIP. The only way to do is basically to cut the pipe and then replace it with something else. On the left picture, we can also see that those small particles, when those hops are disaggregated, it's like 0.2, 0.3, 0.4 centimeters big particles. They can go a little bit everywhere. If you put your hops in the tanks, which is what usually craft brewers do or industrial brewers do as well, they are there in the system. You're going to have to clean them. When you clean those hops, when you purge those hops, they're going to end up also, they usually end up also in the CAP station. They can end up in your spray bowls. Well, it's basically bringing a lot of issues. There is also other issues related to dry hopping. I mean, when we introduce the hops into a tank, it can also lead to nucleation. So there is some quite funny videos sometimes where you can see that craft brewers didn't think of that. They put all their hops in. It was already well carbonated. All the CO2 comes up and half of the tank is basically out of and all on the floor. It's a nice green sea everywhere. Another behavior of the hops is that depending on the types, some of them can actually float and another part can sediment. And in the brewing industry, in the brewing world, we're very used to things that sediment. We have CCTs, we do the yeast sedimentation, we take everything in the cone, we know how to purge the cone, and then as soon as we have a clear enough beer, we send that clear enough beer to the next step, which is usually separation or a filtration step. But what we're less used to is things that are actually floating. And that doesn't really matter how, you can say, the technological level or how advanced, if you have to use that term, the brewery is. It's just very difficult to figure out when that floating part is actually going to come in your pipe and all those solids, those high solids content is actually also going to trigger some issues later on in the process. I mean, if you can imagine that hop layer there is being brought to the next process steps, it's a challenge. And thinking about all those problems, we're looking at like how can we actually solve this? And there's different ways of solving these problems. We took two different paths. One was to try to keep the hops completely out of the system. And another part was to actually still have the hops out of the system, but basically solve those non-homogeneous issues. So today we're going to focus on the left, the system on the left here, which is called the Alhop, and that's the module that keeps all the hops within the system. So the hops are never going in the tank to be dry hopped. It covers also the 4 steps of dry hopping. We like to see dry hopping as 4 different steps. So there's the introduction of the hop pellets, there is the disaggregation of the pellets, then the extraction, the dry hopping process as such, and then the hop removal. When we started developing that system, of course, there were other systems on the market that were also promising to keep the hops out of the main tank. But when we were talking to brewers that had those systems, they usually were clogging. And when we heard that, we thought, okay, we're going to take another approach. We're going to think of cross-flow filtration. And I guess you also are quite familiar with cross-flow filtration. This is based on cross-flow filtration. It's not a cross-flow filter per se. But what we do is we create a hop slurry with the beer to be dry hopped, not all the beer to be dry hopped. We take some of the beer, we hook up the tank to be dry hopped on that system. And with the hop pellets that are contained in the Alhop, we make a hop slurry. And we recirculate that hop slurry with a lobe pump that has very low shear forces. So it has a low shear impact on the product. And we go through a stainless steel wedged wired strainer. And it has an opening of 100 microns. So it's small, it's tight enough to keep the hops from going into the main tank, but it's open enough to let, for example, yeast go through. So yeast won't have any impact on the process here. So that's one recirculation loop. That's the loop that you have inside the system. And the other loop is between the CCT that you want to dry hop, or your beer tank that you want to dry hop, that goes on the filtrate side of the filter. So on the left side, you can see a cut of the strainer. In the center, from left to right, you have the hop slurry circulating, and on the other side of the strainer, from right to left, you have the beer to be dry hopped recirculating over the tank. And now we can have a look at quickly how let's say, more conventional system looks like. It's usually all automated. It's for 100 kilos. But again, everything is contained in the same system. We open the system. It's CO2 flush. We put the hops in. We bring the beer in. We recirculate internally to create that hop slurry for 10 minutes. There is no risk of clogging. The system is very open. We use a lobe pump that can handle hop pellets. And then after 10 minutes, we start this extraction process. After the extraction has been done, the brewer is basically tasting for the first time and see when the aroma profile has been reached. We proceed to, let's say, the hop removal. But it's not very much of a separate step per se, because there is, again, no hops that has been put into the tank. However, you still remain with quite of a large volume of hop slurry. The hop slurry, I forgot to mention that it's around 10% dry solid content. So there's still quite a lot of beer. And you want to, of course, again, recover as much beer as you can during your dry hopping process. So what we do at that point is we close the beer inlet, but we leave the beer outlet open, and we start what we call the concentration process, which is a technique proper to cross-flow filtration. And we start pushing CO2. That's the driving force that will allow us to actually recover the beer trapped in that hop slurry, push it through the strainer while still recirculating internally to avoid clogging. And we're going to do that until we reach a certain viscosity of the hop slurry. And usually we reach quite a thick slurry when we are at around 15% dry solid content. And then we can go a little bit further to recover even more, but we can see that a little bit later. And we did some trials with the VLB, it's the Brewing Institute in Berlin, at the brewery called Berlo, also in Berlin. With our pilot, we were given a tank with 240 hectoliters. We took half, we separated half. One was dry hopped with the Alhop, the other one was dry hopped with the conventional way, dry hopping existing in that brewery. It was a pale ale so 120 hectoliters, 30 kilos of hop pellets, and it was just after the end of the main fermentation, so the beer was still quite warm, you can say, 22 degrees, quite also loaded in yeast. And we started recirculating and take samples on the inlet and the outlet of the Alhop. So the yellow line here represents the evolution over time of the concentration of the hop compounds, and then the blue line on top is the same analysis, but on the outlet of the Alhop. And then on the right, you can see the difference in concentration. So basically, it's the distance between the two lines. And it allowed us to see what's left to extract. And then over time, we were doing that with the brewer, of course, and the brewer was taking a sample, tasting, seeing where we were at during the dry hopping process. And after 150 minutes, he said, okay, we reached the aroma profile. We're done here. You can start the recovery process. And then after 150 minutes, it took us another 40 minutes to recover as much beer as we could out of that hop slurry. That was already quite an improvement, because normally he was introducing the hop pellets in the tank, and then he would have to wait for 2-3 days to reach the aroma profile. And then just a few pictures to show that there is actually really no hops coming out through the filter. There is no particle that go through. You will see a little bit of a haze, but that's basically a reaction that occurs with the polyphenols from the hops reacting with some of the proteins in the beer. But there is no extra significant solid that goes through the filter. And then another picture that is showing the hop slurry after concentration. So that's not the same picture. It looks like the same picture that is just upside down, but it's actually me holding the glass to show that it's actually so thick that it doesn't pour. So we recovered quite a lot of beer here. So in this particular case, we were at around 1.2% beer losses when it comes to dry hopping, or 5 liters per kilos of hop pellets being used. Now, in this case, we didn't use deaerated water. That's something I kept for now. We can also use diafiltration. This is another technique proper to cross-flow filtration. So if the brewery allows, we can use deaerated water to dilute this concentrated slurry again, because there is still beer in it. And based on the calculation, let's say, for example, if you have a 15 plateau beer, original gravity, and you have that amount of hectoliters, that amount of hops, we calculate, and you say, okay, you can deviate from 0.1 by 0.1. It can be 14.9. That's already representing quite a lot of deaerated water. And that deaerated water, we're going to use it to dilute that hop slurry again. And that same amount of deaerated water we put in, let's say we put, for the example, 2 hectoliters, that's going to dilute that beer here that is still there in this slurry. And we're going to proceed again to a concentration step. So we're going to push back that diluted beer in the tank so that we recover, let's say, more extract. And then we like to talk about dry solid equivalence, because actually the dry solid content is still always going to be 15% dry solid content in the slurry. But since it's diluted beer now, if you do the calculation, you can reach, well, it depends how much deaerated water you can actually use. You can reach 35%, 40%, 50% dry solid content equivalent. So it's a very efficient way to cut the losses, you can say. And I think the next slide is my last slide. It's very much to resume what that can offer and how it actually can improve the dry hopping process. Again, we go from days to hours, and we drastically reduce the beer losses. The last trials we did in the US also showed us that we can avoid biotransformation. It's most probably because the contact time between the hops and the beer is very short, and it doesn't leave enough time for the enzymes responsible for the hop creep to pass into the beer, which means that you don't need to wait for the hop creep to happen in your tank and then bottle and can. you can directly proceed. It's also allowing for biotransformation because, again, it has no impact on the yeast. And that's something we still have to try, but it's quite interesting for beers that are being dry hopped several times at different time of the process as well. For example, New England IPAs that need to be dry hopped before, during, after fermentation, during maturation, that would not mix the yeast and the hops together. So you could crop your yeast, for example. That's also something we heard with craft brewers. They said, oh, how do you crop your yeast? How do you reuse your yeast? But it's actually quite complicated sometimes when you have everything that is mixed in the cone, of course. Yeah, but that was it. I don't know if you have any questions. Yeah?
How big is this thing? Like, what size are these tanks, like, and the footprint of this thing?
So the tanks depend on how much hops you need to use, right? So the different sizes are 50, 100, 200, 500, and that's kilos of hops. That's the maximum amount of hops that you can put in. And so far we do a slurry during the dry hopping. We do a slurry of 10% dry solid content. So it means that you need 10 times more in volume. So 50 kilos, 5 hectoliters, 100 kilos, 10 hectoliters, etc. Yeah, footprint is going to be, I think you're going to be around, on the smaller models, 3 on 4, something like that.
What sort of pump have you got for the reset?
Between the tank, the beer tank, and the module here, I mean, it's also on it. There is 2 pumps on it. You have a centrifugal pump, and then the internal one is a lobe pump, rotary lobe pump, bi-lobe. So it allows really a big space in between.
How are you disposing of the spent hops once you're done with the process?
Yeah, I don't know if it's that clear on the picture. You have a drain at the bottom there, and basically we push everything with CO2, or if you can put air on it, of course. We push that slurry through that drain. Usually, what we do so far, there's different brewery, they have different techniques. It depends what you can do with your solid waste. It goes into a container. There is a very large brewery that didn't really care. They just put everything in the drain. That sounds a little bit crazy, honestly, but I don't know how the regulation is in Australia and so on, but yeah, it can take a lot of water to redilute that thing as well. We tried that in the US, and they also pushed everything in the drain, but it's very, very impressive how much volume it can take and how much water you have to add to hose the whole thing and so on. So, yeah. Well, if that's it, I will leave the stage to my colleague.
You hear me? Yeah. So for my part, I will talk about centrifugation, about high-speed separators. We also call it more commonly centrifuge. And the reason we talk about this is because we talk about yield and profitability, and a centrifuge basically is something you cannot miss if you want to improve your yield and your profitability. Yes. But before I go to the slide, I will answer one question that you probably ask yourself is, when should I invest in such a thing? So I can give you a quick rule of thumb, I would say. Of course, there is not one answer to it. Each case can be different. But basically, I consider that if you're producing 200,000 liters per year or more, you should really think about it. Even sometimes it's relevant below that. And if you are producing 500,000 liters per year, then you should have a good reason not to, basically. I don't know here, anyone has centrifuges? Quite a lot already. Okay, so so you guys agree? Yes, I see, yes. Well, I will talk first about some challenges when you consider filtration before we go into centrifugation. Well, if you have been running a filter, you know that clogging and pressure loss will be maybe your daily basis, which is at itself is not an issue, but when you will run production, of course, your pressure loss will increase, and you will, to keep the flow, you will need to increase pressure until a certain point that it's too much, and then you need to clean, right? But in itself, it's not a problem unless you need to stop production because you need to clean. And that's when it's a problem. Because basically you want to finish your batch and you had not planned for intermediate CIP, and then you basically have to change your production planning. So one of the first challenge about filtration is, I would say, production planning. And especially in craft breweries where you have a lot of recipes, sometimes maturation time is not the same between batches, and you end up not knowing in advance if you will be able to run your full batch in once or if you will need to do intermediate CIPs. Another challenge is health. Well, you can mitigate with a mask or these kind of things, but I mean, it depends on filtration type as well. But here I'm referring to Kieselguhr filtration, where the powder of Kieselguhr is not healthy. Then, of course, cost of consumable and disposal will not help your profitability. And another challenge for, let's say, any downstream equipment is DO pickup, which in the large brewery is not so much of a problem because you have some deaerated water. But normally in a craft brewery, deaerated water is something a bit expensive to get. So you end up either to have DO pickup issues or high losses because you drain the first part of your production to avoid oxidation. So you have to mitigate. You may not have filtration and just have just wait the yeast to settle or the hop to settle is the bottom of your tank. And in this case, you have no choice but making, I would say, difficult choice. It's, I would say, yield versus beer quality, or capacity versus yield beer quality, because basically, the yeast settles, and at some point, you need to set a certain volume where you will stop sending to the filling machine, because otherwise you will have too much yeast in your product. So as craft brewers, normally you tend to keep high beer quality level, and then you end up with lots of losses. And of course, we have a solution for this. So you see me coming. It's introducing a centrifuge in the process. And centrifuge is good because it's let's say it's a very versatile, it's a very flexible product that enable not only to improve yield but a number of other things. So the first one is of course remove of yeast and other particles such as hop pellets. So to clarify the beer, right? And that will also help you to have a consistency in your beer quality and a more stable product, we could say. It will, of course, reduce beer losses because you will be able to treat a part of your bottom. And if I can again give us some kind of rule of thumb here, normally with centrifuge, if you have, let's say, a part of your bottom that you normally drain, I would say if you don't have centrifuge, normally a third of it you can recover easily with centrifuge. A third of it you cannot because it's too dense yeast at the bottom. And then the last third is somewhere, if you make some trick, you can recover. And it also depends from case to case, of course. It's also a product that can replace or combine with a filter. In industrial breweries, the initial, let's say, duty of the centrifuge in a brewery when there were only big breweries was to, let's say, prepare the beer for the filter. It was to, remove most of the yeast so that the filter can have long runs. Now in a craft brewery, the standard you're looking for, the haziness you're looking for, enable you to potentially totally remove the filter and still have some quite bright beer because you are kind of accepting a certain level of haze. I've missed something. Yeah, continuous operation. I was referring to it before. There is no, let's say, surprise during production, you can finish your batch as you plan to do it. So of course that's convenient compared to a filtration that can be sometimes a bit difficult. Last but not least, we like to call it, at least in Alfa Laval, a classifier rather than a filter. Well, first of all, it's not a filter. That's the first thing. Because you don't have any, let's say, filtration media with holes and threshold. It works with difference of density. You have the formula here that is called the Stoke law. It's the law that follow centrifugation. So Stoke was an Irish guy that found out that the velocity of sedimentation of a particle into a liquid, so for example a yeast into a tank, is proportional to the diameter of the particle squared multiplied by the difference of density. Maybe I can point out, is this? Yeah, well I'm checking, it's not working. So the square of the diameter times the difference of density divided by 80 times the viscosity multiplied by G, I mean gravity in your tank, and in a centrifuge, of course, we increase this gravity by RW squared, which is rotation speed. Okay. Said that, you understand that the bigger the particle is, the bigger the yeast is, the easier it is to separate it. So what will happen basically is, if I take this typical distribution, where should I point? Maybe here. If I take this distribution of typical lager beer from your fermenter, you have here on this axis particle size, and you see it's in micron, so it goes from 0 to 50 here, and the quantity. So typically you will find a lot of yeast with 6 to 8 micron, typical yeast size, right? But you will also find some bigger ones here, and even bigger, and if we include even ops particles, ops will be somewhere here, right? So considering this formula, it means that if you run a certain flow in a centrifuge, you can draw a vertical line here and say, okay, whatever is on the right, I remove because it's big, easy to separate. Whatever is on the left, I do not remove. And as you change the flow, for example, you reduce the flow, then this vertical line goes to the left and you remove smaller and smaller particles. And that's why we like to call it a classifier, because depending on the flow you will be running at, you will be able to change the outlet beer, basically, the haziness and the quantity of particles. Which bring me to the next slide, I believe. It's an example of our smallest centrifuge, the one we have on our booth. It's a small brew 20, typically go between 5 and 15 hectoliters per hour. You see on each picture, the left is the inlet, and outlet on the right every time, and you see 3 different flows. Basically at 15 hectoliters per hour, we remove, let's say, most of the yeast. At 10, we remove, I think, all the yeast here and maybe some A's from the proteins. And on the right, I mean, it's close to a filter beer. We could say it's a near bright beer, we call it, at 5 hectoliters per hour. It's because we have classified by reducing the flow. I have another example, I think. Here on the Brew 80, here the difference of flow is smaller, so it's a bigger size machine. The inlet is here, and you have outlet for 3 different flows. So we see between 18 and 22, we see a slight difference, and 28 even more. So that means with centrifuge we can get bright beer or hazy beer. We can, by adjusting the flow, we can adjust the haze. And of course, I mean, maybe you're using some filter aids, so biofines, this kind of thing. It can either remove or reduce the amount you're using. So it can be a benefit in cost here as well. Go back to the yield topic. As I said before, when you introduce centrifuge, you can easily recover 30% of your bottoms, so when you were losing. But I mean, the craft industry has been quite, let's say, creative. It's a way to use centrifuge. And here is an example of what you can do. If you have racking arms, and so two inlets, to the tank, you can use the racking arm to start producing. And when this is coming like rather clean beer, I would say, from the to the centrifuge, then you can dose the outlet of the bottom here to the same line. So you reintroduce the bottoms slowly, and then you are able to recover the last third of the volume I was talking about before. Sometimes picture talks more than words. Here is the inlet and the outlet at the same time. We took a sample from a brewery. So it looks like there's nothing to recover here, but actually you can recover some beer. Here's typical numbers you see on the field. Here's an example of a customer having 20 hectoliter fermenter tanks, dosing 22 grams of hops per liter, so quite a lot of hops. And his losses before introducing centrifuge was 6 hectoliter per 20 hectoliter, so quite a lot. But you may see these numbers in your brewery. And introduce centrifuge here just by not even doing some advanced recovery, just use this standpipe. He could recover 10% more from its tank, recovering 2 hecto. When you consider this type of improvement in yield, while your profitability is increasing quite a lot, and it goes, the more volume you do, the quicker it goes, right? That's why I was referring to different production volume before. An example of, let's say, payback of this type of system. Here we took some assumption as well, but pretty conservative, I would say. If you're running 2,000 hectoliters, mostly of IPAs, but with, let's say, a recovery rather low compared to what it can be, and consider 2.5, so it's euros, so it's probably somewhere around 4 Australian dollars, I think, per liter. The return on investment is like 1.5. So pretty quickly it's get profitable. And we have customers that even below 100,000 liters per year get it payback with 1.5 year. I don't know any brewery that has invested in a centrifuge and is regretting his choice. I mean, but some of you have centrifuge. Do you regret or no? And I think I have. Okay, that's a quick summary of what we said. So clear beer with little or no filtering, quicker tank turnover, because of course you don't need to wait sedimentation in your tank. You can process as quick as you like. Of course, you will probably wait that your beer is ready, has right aroma and so on. But when it has the right profile, you don't need to wait to settle. The centrifuge actually prefer homogenized feed than a thick and a non-thick one. Reduce product losses, as we just talked about. Quality and consistency. And I will say even stability, because when you reach a very low level of yeast, it's getting more stable. If you want to combine with a filter, you will definitely increase filtration, and that's why in industrial brewery, any filter has a centrifuge in front. And last but not least, you can control haze in the beer. Okay, it's my last slide, but not least. When you invest in this kind of system, you need to secure performance over time. It's, I mean, in Alfa Laval, we produce centrifuge since 140 years ago, from the 1880, if I recall, when it was first invented for dairy initially. And typical lifetime of a centrifuge is 25, 30, 35 years. So you need to keep, let's say, the machine up and running. So consider, let's say, maintenance. Depends on your volume you're producing, like once a year or so. We have the right, let's say, people to train. We can do, let's say, activity on site such as training, commissioning, maintenance, and we also have training support. Remote, we can also connect to the machine depending on the type. We also have on bigger machine we have what we call condition monitoring, so we can check vibration over time and advise if we need to see any increase in vibration and any maintenance that could be foreseen before any stop is coming. Yeah, and we have this, let's say, politics that we need to be able to deliver parts for at least 30 years. So when you invest with us, you know that we'll be able to bring some parts over time. Thank you very much.
Thank you, Louison and Denis. And thank you very much to Alfa Laval, who have sponsored the keynote speakers room for today. And I'm very pleased to say that is officially beer o'clock for the afternoon, the end of day one. I look forward to joining you all for a beer very shortly. Thank you very much.